Okay, so let's see the question, previous year gate question of welding process. So first one you can see two surfaces P and Q are to be joined together in which of the following process following join sorry in which of the given joining operations there is no melting of the two surfaces P and Q for creating the joint. So the correct answer is, you can see in arc welding, obviously it is a fusion welding in which melting is necessary. And then you can see that is brazing. Obviously in brazing, the filler material can melt, but the base metal is still not melted. And in adhesive bonding, there is no melting either of filler metal and base metal both. Correct? So the correct answer for this question is adhesion bonding. Otherwise, in all remaining options, that is in arc welding, brazing, and spot welding, everywhere some amount of melting takes place. Let's see another question. The types of coated electrode most widely used for welding of low carbon steel. So it is used rutile, that is titanium oxide. TiO2. This is titanium oxide is called as rutile, and it is mostly used for welding of low carbon steel to prevent weld pull to the oxidation for atmospheric oxygen. The joint configuration best suited for adhesion bonding is, so you can see in the butt joint the edge to edge connection takes place, yes or no, in butt joint. And in fillet joint you can see a joint is created like this. Let's say suppose if you want to make a L-shaped joint, then here the joint is produced. This is called fillet joint. And now if I talk about lap joint, so in which one plate is placed over another plate, so this is called as lap joint. And in spot welding, this is a point, yes or no. So the best suited for adhesion bonding is, that is lap joint. Why? Here the contact surface is maximum. Contact surface, this is lap joint, this is fillet joint, and this is butt joint. Correct? And this is obviously spot joint. So the lap joint is the right answer because the contact area is maximum as compared to other joints. So the correct answer is option C. Okay, so let's see another question. The voltage arc length characteristics of DC arc is given. So here V is equal to 20 plus 40 times of L. It is given here where L is the arc length in centimeter. The power source characteristics can be approximated by a straight line. The open circuit voltage is given here, that is 80 volt, and the short circuit current is also given here, that is 1000 ampere. So here we need to find out optimum arc length. Here we need to find out our optimum arc length in millimeter. So simply, as you know that if I talk about linear power source characteristic equation, linear power source characteristic equation, so simply it can be written as voltage upon open circuit voltage plus current upon short circuit current. This is equal to 1. Simply you can see here, if you forget this formula, so you just write this. Let's say if I plot a graph between voltage versus current, so now if I draw a line, then it intersects the I-axis at this point. So this is called as short circuit current, and similarly here we have open circuit voltage. So if you write the equation for this line, so can I say this is current over short circuit current, current over short circuit current plus voltage over open circuit voltage, this is equal to 1. So this is the equation for this line. Is it clear? So now if you put the value of OCB and SCC, so after putting this here we get V over 80 plus I over 1000. This is equal to 1. So V can be written as 80 minus 80 by 1000 I. This is voltage. So for stable arc, can we say for stable arc, For stable arc, simply we can say the voltage corresponding to arc length is equal to the voltage corresponding to transformer, and this is obviously this is the voltage corresponding to transformer. So now if we equate both the voltages, then simply here we get 80 minus 80 by 1000 I is equal to 20 plus 40 times of L. So if you simplify this, here actually we need to calculate I. So can I say this I is nothing but this is 1000 by 80 in bracket 80 minus 20 minus 40 L. So if you simplify this, then here we get 100 by 8 in bracket this is 60 minus 40 L. Correct. So this is voltage is a current is a function of length. So if I calculate power, which is nothing but this is V into I. So if you multiply voltage, that is 20 plus 40 times of L into I, that is 100 by 8 into 60 minus 40 L. Correct. So if you simplify this expression, then here you get, let's say if we take common, that is 100 by 80, this is the common term for this multiplication. And now if you multiply 20 plus 40L times 60 into 40L, so simply here I am writing 60 into 20, this is 1200 plus this is 2400 L minus 800 L minus 1600 L square. Is it clear? So this is a power, correct? So again if we simplify this expression, so simply here we get this is 1200 plus, if you subtract 2400 minus 800, so here we get 1600 L minus 1600 L square. Is it clear? So now you can see for maximum power, it's say, can I say this is del P by del L is equal to 0. If you differentiate this expression, so simply here we get 1600 minus 3200 L equals to 0. So from this here we get 1600 over 3200. This is 1 by 2, or simply you can say 0.5 centimeter. Or if you represent this term in millimeter, so can I say this is 5 millimeter. So this 5 millimeter is the right answer. This is the right answer. So according to this, if I see the correct option, so the correct option is option C. Is it clear? So like this you can solve this problem. Okay, so let's see another problem. High alloy steel components are preheated before welding for reducing. You can see high alloy steels are preheated. Why? Because when you start welding, then huge amount of stresses may induce because of non-uniform heating. Correct. And because of this, it may some cracks takes place, or the component where you weld may distort it. So the reason behind here we need to prevent this distortion or crack. So we just we just preheat the weld surfaces. Yes or no? So the correct answer is welding stresses. Is that clear? So preheating is always before done to prevent welding stresses. If you prevent welding stresses, then obviously distortion and cracks type defects may eliminated. Okay, let's see another question. Which increases point joint thickness, the tensile strength of a brazed joint? So you can see in brazing, if this is a crack, this is a crack. Is it clear? So when you perform brazing, then obviously we just filled this crack with the molten metal. Yes or no, like this. We just filled the metal by the molten metal. So if this gap is more, obviously, then more amount of metal may be deposited here. So initially when this gap, let's say this is a height h, if this height h will increases, then the strength will increases also. Why strength increases? Because the amount of metal deposited will be increases. But after a certain limit, if you increase too high crater or this crack, then obviously the strength will start decreasing. Why strength will start decreasing? Because when you have higher crater or higher cracks, then when you pour the brazed material, then obviously the strength of the brazed material is lower than the parent metal. That's why its strength starts decreasing. Correct? So if I plot a graph between strength versus this crack, then obviously when initially the scrap is more, then the strength will be increases, then it starts decreasing. Is that clear? Then it starts decreasing. Is that clear? So the correct answer is first increases and then decreases. The mode of metal transfer in CO2 MIG welding. Correct. So in CO2 MIG welding, globular transfer takes place, and most of the books you get this answer, but this is wrong. And you can also check this option in P.N. Rao book, Manufacturing Process Volume 1, P.N. Rao. You can also check in this book. And what about globular transfer? In globular transfer, actually, we use slightly larger current. Is it clear? Here we use slightly larger current than short circuiting metal transfer. Is that clear? And when you use more current, then a larger size of globules may form. And when this globules touches the surface of the workpiece, then short circuiting takes place and then it will detach. And since the size of this globule, size of this droplet is significantly larger, therefore due to gravitational force, due to gravitational force it may detached, it may detached with the electrode. Is that clear? So since here gravity may play a very crucial role, so this kind of metal transfer is only suitable for flat or horizontal welding position. Horizontal welding position means simply you can say out of the position, this mode of metal transfer is not used. And remember, this type of metal transfer is only occurs when we use in the MIG welding, when we use in the MIG welding, when we use MIG welding with CO2 gas, MIG welding with CO2 gas, then globular transfer takes place. Globular metal transfer metal transfer takes place. Is it clear? So the correct answer is option C. Okay, so next question you can see in an interchangeable assembly, shaft of size this made with hole of size this. This is shaft and this is hole. The maximum interference, actually here we need to calculate interference. So let's see, if I talk about the maximum size of shaft. So this is nothing but this is 25.040. And what about minimum size of shaft? So simply if I say, then it can be written as 24.990. Is that clear? And similarly, if I talk about for hole, so the maximum, size of hole is nothing but this is equal to 25.030. And if I talk about minimum size of hole, then it becomes 25.020. 25.020. So you can see here, suppose if I say this is a baseline, so the size of, so the whole size is represented like this, correct? This is basic size, correct? So this represents hole tolerance. Here we have 0.020 and here we have 0.040. And similarly, if I represent the shaft tolerance, then you can see here it is looking like this. Sorry, this is not 40, this is 30. Let me correct. And if I talk about the hole tolerance, then you can see here it is looking like this. Sorry, this is shaft tolerance, not hole tolerance. This is shaft tolerance, correct? Here we have 0.040 and here we have minus 0.010. So actually we need to calculate maximum interference. Maximum interference, you can see. So how much maximum interference? So the maximum interference is nothing but the minimum size of the hole and the maximum size of the hole. This difference is called a maximum interference. Actually, if I talk about fit, so here we have three types of fit: clearance fit, transition fit, and interference fit. Interference fit means when the size, minimum size, actually if I talk about this, then here we get some transition fit, yes or no? But if I talk about the maximum and how much maximum interference takes place, so it can be written as, yes, it can be written as, if I talk about interference, so this actually this is called a maximum interference. This is actual interference, correct? And this is nothing but this is 10 micron. 10 micron. This is nothing but this is 10 micron. Actually, if I talk about interference, so this is nothing but this is it is a difference between maximum size of, sorry, minimum size of hole. Actually, if I talk about this, minimum size of shaft minus maximum size of hole. This difference is called as interference. But here we have transient fit, clearance fit, as well as interference fit. So if I talk about only interference part, then this will be an interference part, and if I see this part, then this will be a transition fit part. Is it clear? This is a transition zone, and this difference is belongs to clearance fit part. Yes or no? So here we have all kind of fits. So the correct answer is option D here. Okay, so what about this? Which of the following powders should be feed for the effective oxy-fuel cutting of stainless steel? So the correct answer is steel. Actually, when you feed steel on oxy-fuel cutting, then oxygen react with steel produces iron oxides, and which helps the metal cutting. During gas, next question you can see, during gas welding of copper steel sheet, a natural flame was used, that is the 8 liter of acetylene, but weld was found to be defective. So it was re-welded using oxidizing flame. So you can see in oxidizing flame, the quantity of oxygen is always more than the acetylene. So if you use 8 liter acetylene, then definitely the quantity of oxygen is more than 8 liter. So the correct answer is option C. Why not I am selecting 16? Because it is slightly higher than the acetylene, actual size of acetylene से थोड़ा सा ज्यादा हम यहाँ पे ऑप्शन प्रोवाइड करते हैं. So the correct answer is 10. This is not right answer. The type of coated electrode most widely used for welding of low carbon steel, then I already discussed with you, that is rutile, that is titanium oxide. Okay, so let's see this question. Two mild steel plates of similar thickness in butt-welded joint configuration are welded by a gas tungsten arc welding. So here we weld butt joint. So if I talk about butt joint, so can I say this is a butt joint? This is a butt joint. This is a butt joint. So this is the cross section area. This is AW. And let's say this is a electrode wire whose diameter is 3 millimeter. It can be feed along this direction with F speed, and this is also moves along this direction. This is called VW, that is welding speed. So here you can see the filler wire of the same metal, mild steel material, having 3 mm. So this is 3 mm. It is already given here. Welding voltage, current and speed are also given. This is VW. Correct? This is voltage capital V. This is current, that is capital I. And the filler wire feed rate is selected such that the final weld bead is composed of 60% of volume of filler and 40% volume of base plate. So whatever here the melting takes place in this welded joint, so out of this total welded joint, simply you can say the 60% of this area belongs to filler wire, or simply you can say filler material. Correct? And rest of the part, that is 40% of the material, is belongs to base metal. Now you can see the melting requires 10 joule per millimeter cube. So the if I talk about the heat required for melting, that is HM, this is 10 joule per millimeter cube. 10 joule per millimeter cube. Is it clear? And the heat transfer factor means eta st, it is given here, that is 0.7, and the melting factor eta m is also given, that is 0.6. So here we need to calculate feed rate in millimeter per second. Correct? So this is all about question. So while solving this question, first if we can use the melting efficiency is nothing but this is Vi, or simply you can say heat required for melting over heat supplied. So from this can I calculate heat supplied, which is 10 joule over 0.6. So simply here we get melting efficiency is 0.6. So here we get 100 by 6. 100 by 6. Yes or no? This is HS. And now if I write HM, then this is nothing but this is VI power over area of the cross section into velocity AW into eta ST. So HM is nothing but this is 10 joule, which is already given in the question, which is equal to VI. V is also given, that is 20 into I is given 150 ampere over AW. We need to calculate AW, and VW is also given, that is 5 millimeter per second, and eta efficiency, that is 0.7. So from this if I calculate AW, then here we get, let's see, first I calculate. So this is 20 into 150 into 0.7 over 5 over 10. So this is 42 millimeter cube. So this is the total weld area, but only 60%. If I write the how, if the welding speed is VW, so can I say the volume feed rate, volume of metal feeded is equal to volume of metal, or you can say the volume of metal melted, or simply you can say deposition rate. Deposition rate is equal to, can I say this is AW into VW, and what is deposition rate? Feed rate of the filler rod into cross section area. So this is pi by 4 d square is equal to AW into VW, but this is total volume, and the deposition rate is only up to 60%. So can I multiply with this? 60% means 0.6. Yes or no? So after this you can see, if I put all the values here, so simply it can be written as 42 into 5 into 0.6 over 5 by 4 into d square, that is 3 square. So if I calculate this, then simply here we get 10.67 millimeter per second. Correct? Oh yes, here I make a mistake. Let me correct it. This is not HM, this is HS actually. This is HS, and this is nothing but this is 10 by, sorry, 100 by 6. And after that, if you put this value, then here we get 25.2. Now it is correct. This is 25.2 millimeter square. Okay, so let's see, let's just correct it, and instead of 42 here actually we have, that is 25.2. And now if you calculate, then obviously you will get this answer. Let me check once again. Yes, 10.69, 10.69 actually, 10.69 millimeter per second. This is the answer. This is the answer. So like this, you can solve this problem. Is it clear? Like this, you can solve this problem. So this is very nice question. And if you do more and more practice, then you can able to solve this kind of question. Otherwise, during the exam and exam temperament, it is very difficult to handle such types of question. Correct? Okay, so let's see another question. In this question, you can see a spot welding operation performed on two pieces of steel yielded a nugget with a diameter of 5 mm. So here we have spot welding in which the diameter of the nugget is 5 millimeter and the thickness, or simply you can say height of the nugget, this is equal to 1 millimeter. The welding time is also given here, that is, let's say if it is represented by t, small t, that is 0.1 second. The melting energy for steel HM is given here, that is 20 joule per millimeter cube. Assuming the heat conversion efficiency, that is melting efficiency is given here, that is 10%. The power required for performing the spot welding, we need to calculate this. So if you can see, HM is given here, but this is given for joule per millimeter cube. So the actual heat supplied is equal to, can I say, let's say if I represent this is small hm, specific heat. So hm is nothing but this is a small hm into volume of the nugget. So simply it can be written as this is 20 joule into pi by 4 into diameter, that is 5 square into thickness 1. So from this, after calculating here, we get 20 into, this is 392.8. This is 392.8 joule. So if I calculate power, so can I say this much amount of heat required for melting per unit time? Correct. So it becomes 392.8 over 0.1 joule per second. So from this here we get power is nothing but this is 392 3928 watt. Yes or no? Correct. But the efficiency, conversion efficiency is given here, that is 10%. So actual power, if I calculate, so simply can I say this is nothing but the power divided by efficiency. So 3928 over 10% efficiency means 0.1. So this is 3928 watt, or simply you can say 39.280 kilowatt. 39.280 kilowatt. This is actual power required, actual power supplied. Is it clear? So this is called as actual power supplied, that is 39.28 kilowatt. Okay, next question you can see, two plates each of 6 millimeter thickness are to be butt welded. Consider the following process and select the correct sequence in increasing order of the size of heat affected zone. Correct. So the in the increasing sequence. So out of these, the maximum heat affected zone will be obtained in submerged arc welding. Is it clear? So this must be at and arc welding, MIG welding, laser beam, and submerged arc welding. So consider the following process and select the correct sequence in increasing order of size of the heat affected zone. Increasing order. So the minimum heat affected zone will be there in 3. So either you can see option A or option B. These two options are wrong. Correct? So A और B में कोई सा सही हो सकता है. Next 4 and then next you can see the MIG welding. Yes, this is laser beam, then MIG, then submerged arc welding, and then arc welding. Yes or no? Yes, so the correct answer is option B, not option A. Why? Because heat affected zone in submerged arc welding is larger than the MIG welding. Is it clear? Submerged arc welding में heat affected zone MIG welding से ज़्यादा मिलने वाला है. That's why this is wrong answer. Okay, next question you can see a gas tungsten arc welding operation is performed using current of 250 ampere. Here the current is given, that is 250 ampere, and arc voltage of 20 volt at a welding speed of 5 millimeter per second. Assuming that the arc efficiency is 70%, the net heat input per unit length. Here we need to calculate heat supplied per unit length of the weld, means kilojoule per millimeter. We need to calculate. So you can see here, if I say the net heat input per unit length of the weld will be, so you can see so simply if I write HS is equal to VI upon AW into VW into eta HT. So HS, here the area is not given. So simply can I say the HS is equal to VI upon VW into eta HT. Correct? So you can see V is given, that is 250 into 20. Arc efficiency is 70%, means this is heat transfer efficiency. Correct? And VW is also given here, that is 5 into 0.7. So this is HS. So now if I talk about unit, so VI is nothing but this is watt. So Newton meter per second over velocity is nothing but this is meter per second, millimeter per second. Okay, so here actually we need in joule. So let's say this is joule. Correct? So this is cancel out. So this here we get joule per meter or joule per millimeter. Is that clear? So simply you can say here, if you calculate this, so HS is nothing but this is 700 joule actually per millimeter. And if I talk about velocity, yes, millimeter. So this is joule per millimeter, or you can say 0.7 kilojoule per millimeter. This is the answer. This is the correct answer. Yes or no? So which of the following welding methods provides the highest heat flux? So in this welding, if you see, the correct answer is laser beam. Actually, laser beam provides you a maximum heat flux, means amount of heat per unit area. That's why with the help of laser welding, very deep fine hole can be cut with the help of laser beam, which is not possible by other process. Okay, so a welding operation is being performed with a voltage of 30 volt. Voltage is given, that is 30 volt. Current is also given here. This is equal to 100 ampere. The cross section area is also given here, that is 20 millimeter square. This is weld bead cross section area. The workpiece and filler are of titanium, for which a specific energy of melting, means this is HM per unit volume, that is 14 joule per millimeter cube. Assuming a thermal efficiency of the welding process, means the eta HT is 70%, the welding speed. Here we need to calculate welding speed. So you can see here in this question, you can say if I write heat supplied, so can I say this is Vi over area of the weld into velocity of the weld into eta st, correct? And melting efficiency is nothing but this is hs by hm, sorry, hm by hs, correct? Hm by hs, is it right? So you can see in this problem actually, here we have melting efficiency, not eta st. Yes or no? If eta st is not given, so simply I assume eta st is equal to 1, correct? So from this, can I say hs is equal to hm, that is 14 joule per millimeter cube over zero point 0.7. So this is 20 joule per millimeter cube. So from this expression, if you put this value, then this is 20. V is given, that is 30 into 100 over AW, that is 20 millimeter square into VW, you need to calculate, and melting efficiency is assumed to be 100%, that is 1. So from this, VW is nothing but 30,000, sorry, 3,000 over 20 into 20, 150. Let's say this is 30 by 8, 30 by 4. 7.5 millimeter per second. This is the answer. Is that clear? Okay, so let's see another question. The type of weld represented by this shaded region in the figure is, so the correct, this kind of weld is called fillet weld. Okay, so next, heat is removed from the molten metal of mass 2 kg. Here the mass is given at a constant rate of 10 kilowatt till it's completing solidified. The cooling curve is shown in figure, assuming uniform temperature throughout the volume of the metal during solidification. The latent heat, so you can see the only we have latent heat at this temperature only, at this zone only. So if you project this, then simply here we get this is 20, correct? So time is 20, and if I write latent heat, so this is nothing but this is m into L. So the constant rate of heat is given, that is 10 kilowatt, correct? And the mass flow rate is, if I talk about mass flow, this is kilowatt, and we need to find this value in kilojoule per kg, kilojoule per kg. So first we need to, you can say this is a latent heat which is 10 kilowatt. constant rate of the heat is removed from the constant. By this rate we remove the heat. Yes or no? Actually, this is Q. This is not latent heat. This is Q. So Q is nothing but this is m dot latent heat. Correct? So the latent heat is nothing but this is Q by m. So Q is nothing but this is 10 kilowatt over m, that is 2. So this is 5 kilowatt. But here kilowatt per kg. So but here we need to determine this value in terms of kilojoule per kg. So kilojoule. So we need to, this is kilojoule per second. Correct? So if you multiply with time, means 5 into here how much time is taken. So this is 10 second. Then it will be written as kilojoule per second into 1 by kg. Correct? This already this is given here. So after writing this, you will get 50 kilojoule per kg, and this is the answer. So this is all about unit match. करेक्ट. अगर आपको यूनिट पता है, यूनिट एडजस्ट करना आता है, देन यू विल इजीली सॉल्व दिस क्वेश्चन. So the correct answer is 50 joule kilojoule per kg. This is the right answer. Okay, under optimal condition of the process, the temperature experienced by a copper work with piece, fusion, welding, brazing and soldering are such that you can see the melting temperature of welding is more than brazing. So the correct answer is this: welding, then brazing, then soldering. The welding process, which uses a blanket of fusible granular flux, is, this is called submerged arc welding process, in which we use fusible granules. Which types of which two of the following joint processes are autogenous? Autogenous means welding without filler material. Autogenous means welding without filler material. Welding without filler material. Is it clear? Welding without filler material. So you can see here in diffusion welding there is no use of filler material, and friction welding is also there is no use of filler material. So option 1 and 4, option A is the right answer. In a linear arc welding process, the heat input per unit length is inversely proportional to. So the correct answer is welding speed. Within the heat affected zone in a fusion welding process, the work material undergoes microstructural change but does not melt. Yes, in heat affected zone there is no melting. If I see this is the welding. So you can see here this is the fusion zone where the complete melting of the base metal takes place. So you can see from both sides, this is the zone which is called as heat affected zone. This is HAZ, and in this HAZ zone there is no melting, only microstructural changes takes place. So option A is the right answer. Next question, in a solid state welding, the contamination layer between the surfaces to be welded are removed by, it is only possible by plastic deformation of the material. The major difficulty during welding of aluminium is due to, aluminum is a very reactive metal which reacts with oxygen produces aluminum oxide. So the correct answer is high tendency of oxidation. And if it makes oxides, then it becomes ceramic, which is insulator. So it is not possible to weld. Okay, match the correct one. Friction welding. So it is mainly used for welding of dissimilar metals. Gas metal arc, consumable electrode wire, electroslag welding, joining of nickel thick plate, tungsten inert gas welding, non-consumable electrode. So the correct answer is 4, 3, 2, 1. Yes, option A is the right choice. At a small variation of arc length at operating condition, the manual metal arc welding transforms provide nearly, you can see in the manual welding process we use drooping characteristic like this, and if I select 2 points, the drooping characteristics, so you can see here the change in, this is the voltage. So this is change in voltage and this is change in current. So change in voltage is very very high as compared to change in current. So this is constant current characteristic machines. So the option D is the right answer. Penetration is increased by, how to increase penetration? Increase welding current and welding speed. No, this is not answer correct. Increase welding current and decreasing welding speed. Increasing welding current and decreasing welding speed. Yes, if you increase the current and decrease the welding speed, then penetration, more penetration takes place. Under the optimal condition of the process, the temperature experienced by the copper work. Obviously, this question is de-welding, brazing, welding, brazing, and soldering. Okay, so now you can see during a steady state, during a steady gas metal arc welding, the direct current electrode positive polarity, the welding current voltage are given here. V is given, that is 30 volt. Current is given, that is 150 ampere. And the welding speed is also given, that is 6 meter per minute. Or you can say this can also be written as 6000 by 60. So it becomes 100 millimeter per second. This is very fast welding. A metallic wire electrode of diameter D is given, that is 2 millimeter. Sorry, not 2. This is 1.2 millimeter. It's being fed at a constant rate of, feed rate is also given, that is 12 meter per minute. Means 12,000 over 60. So simply here we get 100 millimeter per second. The density of specific heat and melting temperature of the electrodes are given here. Density is 7000 kg per meter cube. And if you convert this in millimeters, so it can be written as 7000 into 10 power minus 9 kg per millimeter cube. So these are the information which is already given in the question. So now you can see uh, specific heat, that is C, is also given here. This is 500 kilojoule per, joule per kg. At a temperature of 1530 degrees centigrade respectively, assuming ambient temperature, let's say T1 is 30 degrees centigrade. The latent heat of melting, neglecting the latent heat of melting, further consider the two-thirds of the total electrode power is available for melting of the wire. Means melting efficiency is two-thirds. The melting efficiency, this is eta st actually, and we need to calculate melting efficiency. So the melting efficiency is nothing but this is Hm by Hs. Hm is nothing but this is mcp delta T over Vi upon Aw into Vw into eta st. So now you just put the value. So mass is nothing but, so you can see the filler rate is nothing but this is 1.2. So when, if I talk about deposition rate, so this is nothing but this is pi by 4 d square into f. So this is pi by 4 into 1.2 into f, that is 200 millimeter per second. Correct? So if you multiply this deposition rate with density, then it gives us mass flow rate. So simply you put this value like this, pi by 4 into 1.2 into 200 into density, that is 7000. Or let me see, first I calculate mass. Correct? So Let's say this is equation 1. So this is a volume flow rate. So if I write mass flow rate, so can I write volume flow rate into density? So this is pi by 4 into 1.2 square to 200 into density is 7,000 into 10 to the power minus 9 kg per meter cube. So from this here we get mass flow rate in kg per second. So this is square. Why I forget to write every time. So it becomes 0.001583 kg per second. Correct. And once you get this mass, so simply I use eta m is equal to mc delta t. So this is 0.001583. This is kg per second. Specific heat is given, that is 500 joule per kg. Delta T is nothing but this is 1530 minus 30 over welding current and voltage is given here 30 150 and VW is uh, 30 into 150 over VW is given, that is 6, sorry, not 6, 100 millimeter per second. VW is 100 millimeter per second. Correct. And what about area? Okay, so this is, if I talk about its unit, then it will be in joule. And dot, so this is kg per second, this is joule per kg, so kg cancel out. And delta T, joule per kg, actually per kg Kelvin hona chahiye. Is it clear? Now it is correct. So here we have in joule per second, so simply here we write this only. And eta heat transfer efficiency is also given here. How much? That is 2/3. So let's see if I calculate this value. So yes, so after, and you also if you multiply 100, then after calculating here we get 39.59%. So according to this, the correct choice is option A. So this is a little lengthy question, but if you focused on the question, then you can easily solve if you know the basic principle and fundamentals. Okay, so what about this question? Once again, from resistance welding. A resistance spot welding of two steel sheets is carried out a lap joint configuration using a welding current of 3 kilo ampere. Here the current is 3000 ampere with a welding time of 0.2 second. A molten weld nugget of volume of weld nugget already given here, that is 20 millimeter cube is obtained. The effective contact resistance is also given here, that is capital R is equal to 200 micro ohm. The material properties of the steels are given here. Latent heat is given, that is 1400 kilojoule per kg. Density is given, that is 8000 kg per meter cube. Melting temperature is also given here, that is 1520 degrees centigrade. Ambient temperature is given here, that is 20 degrees centigrade. Specific heat is also given here, that is 0.5 kilojoule per kg degree centigrade. So here we need to calculate heat in joules dissipated to the base metal. So actually here we need to calculate HT, that is HS minus HM. Correct. So how to calculate? You can see here. More number of parameters are given here. So if I write HS, then this is nothing but this is VI over VW. Is there any welding? So, oh, this is resistance welding, so I'm not using this formula. For resistance welding, the heat supplied is written as I square RT. Is it clear? This is 3000 whole square into 200 into 10 to the power minus 6 into 0.2. So if you multiply this, then here we get, let's see, 3000 square into 200, 1800 into zero point 0.2. So it will be a 360 joule. This is heat supply. And similarly, if I calculate HD, then it can be written as, sorry, not HD, this is HM. So it can be written as MC delta T plus ML. So what about mass? Mass is nothing but this is density into volume. Density is given 8000 kg per meter cube into volume is 20 millimeter cubes. So let's say this is multiplied with 10 to the power minus 9. So this gives us kg mass in kg. So you can see 8000 into 20 divided by 10 to the power 9. So here we get 1.6 into 10 to the power minus 4 kg. So let's say HM is nothing but this is 1.6 into 10 to the power minus 4 kg. Into specific this is 0.5, and obviously this is written in kilojoule. So can I say this is 500 kilojoule? Sorry, 500 joule into 1500. Delta T is 1500. This is 15 and 20 and 20. So this will be 1500 plus ml, and latent heat is also given here, that is 1400 kilojoule into 10 to the power 3, like this. So from this if I calculate, (344 joule). So now if I calculate heat dissipation, so this is nothing but this is HS minus HM. So this is 360 minus 344, and if you simplify this, then you will get 16 joule. This is the amount of heat which can be dissipated into the atmosphere, that is HT is equal to 16 joule. This is the correct answer. So according to this, the correct answer is option B. Okay, what about this? Resistance spot welding of two steel sheets is carried out in a lap joint configuration by using a welding current of 3. Again, this is from a resistance welding process. So welding current is given here, that is I is equal to 3000 ampere. And this is same question. So can I directly give the answer? Heat in joules used for production weld nugget will be assuming 100% heat transfer efficiency. So amount of heat actually. So this is a continuous question. There's as a previous one. So here we need to calculate how heat used for producing weld nugget. It means here actually we need to calculate HM. So in the previous question you can see the HM is nothing but this is 344 joule. So simply you can also calculate by using this formula MC delta T plus ML. And we already calculated in the previous slide. So directly I'm writing here, that is 344 joule. Correct, 344 joule. So this is the correct answer. Correct. Already we calculated in the previous slide. You can see here like this. This is the MCP delta T, MC delta T. M is calculated by this, and once you get m, so you just put these values on this expression, then you will get the answer. Is it clear? That's why I'm not again writing this question. Okay, so which pair amount of the following solid state welding process uses heat from an external source? Heat from external source. So obviously, if, in a forge weld use external source heat, so this option is wrong. And diffusion welding, friction welding, yes, diffusion welding is also. So P and S is the correct answer. Friction welding itself produces heat while during welding, and similarly in ultrasonic welding. A sound welding joint should not only be strong enough but should also exhibit a good amount of ductility. And the welded process is used for fabricating mild steel components only. So this, you can say, reasoning is wrong. So A is true but R is wrong. So option C is the right answer. Consider the following statement. The magnitude of residual stresses in welding depends upon metal melted deposited, design of weldment, supports and clamping of component, welding process. So it depends on welding process, design of weldment, and metal melted. So 1 to 4, option A is the right answer. Consider the following statement. The size of the heat affected zone will increases with increased starting temperature, increased welding speed, increased thermal conductivity of the base metal. This is right. Increase in base metal thickness. Yes, it is also right. Correct. So 3 के साथ 4 कोई option ही नहीं है. So this is not right answer. So this is wrong. Increase starting temperature. Yes, it is right. Increase welding speed. No, this is wrong. So 1 and 3 only. So option B is the right choice. Correct. Okay, match the following list 1 and list 2. First, in list 1 we have causes, and list 2 we have welding problems, and list 2 causes. Cracking of weld, porosity, inclusion. You can see first, you see these two defects. Porosity, high excessive stresses, failure of remove this excessive this welding atmosphere. So yes, porosity is mainly caused due to option 5. So C5, you can see C5 is given. Yes. So this option and this option is wrong. Next, inclusion. Exclusion is mainly happens due to high joint rigidly failure removed slag. Yes, option 3. So D3. So D3 in both options we have. So next, cracking of the weld metal. Cracking of the weld metal due to excessive stresses. So for this excessive stress, so 1. A1. Neither of the options we have A1. So B1, cracking of base metal, if we use yes, so for this we can also choose. So A2, high joint rigidity. Correct. So this is 2. So the correct answer is option A. In a fabrication, saw teeth joint is to be made between two plates using this space. The welding symbol. You must remember this option. This is the welding symbol. This is the welding symbol. Correct. Match list 1 and list 2. Spatter, arc blow, distortion, poor joint selection. So D4, no D4. Sorry, B4. Yes, B4 or A2. B4, A2. So A2. Either of this. Slag inclusion, improper cleaning. Yes. So C3. So option D is the right choice. Correct. And next you can see arc welding, friction welding, solid welding, laser, diffusion, polar. Okay. So arc welding, if I say, then polarity related to arc welding. So P2, only one option we have. Friction welding, that is kinetic energy, yes. Solid state welding, this is called diffusion, 1241, yes. And laser welding, yes, focusing. So option D is the right choice. The cold crack susceptibility of the heat affected zone in an arc welding is influenced by entrapment of hydrogen, cold cracking, residual stresses, Martin-static transformation, Q and R. Is there any option? No. Q and R. Uh, Slide inclusion. No. Q and R is necessary. So you choose accordingly. P and S. No, it is not correct answer. R and S. Martin-static. Martin-statically transfer. No. So actually, only these two are the main parameters. So accordingly, if I select Q and R along with P, so option C is the right appropriate answer, not exactly correct answer. This is appropriate answer. Which of the following powders should be fed for the effective oxy cutting? Is steel. This is a repeated question. The strength of the brazed weld joint increases up to certain gap, then start increases up to certain gap between the two joint surface beyond which it start decreasing. I already discussed with you in the previous one. Next, match of the following work material: aluminium, disteel, copper, and titanium. Aluminium mainly used for atomic hydrogen welding. So P4. Is there any option? Yes. Option C is the right answer. The atomic hydrogen welding is mainly developed for the welding of aluminium alloy. Is it clear? Let's see other options also. Disteel, some welded by submerged arc welding. Copper wire, copper wire is welded by laser beam welding. With the work material and types of joint. Titanium sheet, obviously then titanium sheet, soldering. How it is possible? So let's see. Once again, review all the options. So for the aluminium, atomic hydrogen welding is the right choice. But if instead of this, if I choose another option, that is soldering, this is not possible. So option A is wrong. 6. Laser beam welding, this is also wrong. Okay, yes, gas tungsten arc welding is also used for welding of aluminum. So option D is the more correct than previous one. Q4, disteel, atomic hydrogen welding, copper, soldering. Yes, copper is used in soldering, copper wire, titanium, laser beam welding. Yes, option D is the more appropriate answer. Correct. For butt welding of 40 thick steel plates, when the expected quantity of such jobs is 5,000 per month over a period of 10 years, choose the best suitable welding process. 5,000 per month, you can see, means approximately 130 components per day welding we need. Choose the butt welding of 40 For thick sheet joining, oxy-acetylene gas welding is not suitable. Electron beam is also not suitable. The correct answer is submerged arc. MIG welding is also not suitable. Submerged arc welding is the right choice. Correct. It is mainly used for welding of thick sheet. Submerged arc welding especially. Preheating before welding is done to prevent a distortion. Correct. Prevent a distortion. This is the right option. The ratio of acetylene to oxygen is approximately for neutral flame used in the gas. Neutral flame, approximately both gas are used in same ratio. Same ratio, 1:1 is the right answer. 1:1 is the right answer. So this is all about all the welding question. So thank you for watching this lecture.